Hello guys, this is Bhupender Singh and you're watching our YouTube channel SME Dehradun. Today I will tell you how you can measure temperature, pressure and altitude using a BMP180 barometric sensor with Blynk2.0 IoT mobile app and web dashboard and display them to OLED. So guys, to design this project you need the following components: NodeMCU ESP8266 or ESP32 Wi-Fi board, BMP180 barometric sensor, 128x64 I2C OLED display and few jumper wires. And this is the circuit diagram of interfacing BMP180 sensor and OLED with NodeMCU. You need to connect your hardware according to this circuit. If you are using an ESP32 board, then connect your hardware according to this circuit diagram. You can download these circuit diagrams from the video description. Now we connect the hardware. This is a breadboard. This is 128x64 I2C OLED and it has 4 pins: ground, VCC, SCL and SDA. This is a NodeMCU ESP8266 Wi-Fi board. This is a BMP180 sensor. It also has 4 pins: VCC, ground, SCL and SDA. Now I am going to place NodeMCU on a breadboard. Now place the OLED. Take 4 male-to-male wires and connect the ground and VCC pin of the OLED to 3.5 volt and ground pin of NodeMCU. Now connect the SDA pin of OLED to D2 pin and SCL pin to D1 pin of NodeMCU. Now place the BMP sensor on breadboard. Take more 4 male-to-male wires. Connect VCC and ground pin of the BMP180 sensor to 3.3 volt and ground pin of NodeMCU. Connect SDA and SCL pin of BMP180 sensor to D1 and D2 pin of NodeMCU. If you are getting confused somewhere in connections, then take the reference from the circuit diagram. And guys who are using ESP32 board on this project, remember that pin number 21 is SDA and 22 is SCL pin in the ESP32 board. Now configure the Blynk Web Dashboard. Open your web browser and open the Blynk.cloud website. You can create your new account or login through your username and password here. After login, you will see the Blynk dashboard. You can create your project template here. So click on the new template and template property gets open. Write your project name like BMP180 sensor with Blynk2. Below, select hardware as ESP8266. If you are using an ESP32 board, then select the ESP32 here. Choose the connection type Wi-Fi. Add the description, write your project description like BMP sensor integration with Blynk2 and click on done. Once you have done it, you will see the info tab. Here you will see the firmware configuration. It is template ID and device name. This is very important. We need to write it in our Arduino program. Now click on the Metadata tab. Here you can see the information like project owner, device name, location, etc. about the project that we have just created. In the data stream tab, we define the method of accessing the pins of NodeMCU to Blynk like through virtual pins, analog pins or digital pins. So we go ahead with virtual pins. Click on the new data stream and choose virtual pin. Virtual pin property gets opened. Write the name as temperature, virtual pin as V0 and data type as double. Search and select unit as degree. Change max value to 100 and click on create. Again click on the new data stream and choose virtual pin. Virtual pins property gets opened. Write the name as absolute pressure, virtual pin as V1, data type as double. Change the max value to 5000 and click on create. Again click on the new data stream and choose virtual pin. In the property, write the name as SL pressure, virtual pin as V2 and data type as double. Change max value to 5000 and click on create. Again click on the new data stream and choose virtual pin. In the property, write the name as computed altitude, virtual pin as V3 data type as double and select the unit as meter and max value to 5000 and click on create. So this is how we can create virtual pins. Now click on the events tab where you can create any notification for your events. By default, here are two events, online and offline. If you want to create more notifications, then you can create by clicking on add new events. Now we go to the web dashboard. Here we drag and drop the widgets for our virtual pins. So we drag and drop 4 gauge widgets in the web dashboard and arrange them as per our requirements. Now we drag and drop the 4 labels in the web dashboard. Now hover the mouse cursor on the first gauge and you will see the setting icon on it. Click on it, property gets opened. Click on add data stream and select temperature V0 and click on the save button. Now open the setting of second gauge, click on add data stream and select absolute pressure V1 and click on the save button. Now open the setting of third gauge, click on add data stream and select SL pressure V2. Change the color of the gauge to navy blue and click on the save button. Now open the setting of fourth gauge, click on add data stream and select computed altitude V3 and click on save button. Now we configure the labels. Open the setting of first label, click on add data stream and select temperature V0. Turn on the switch for the background color of the label and click on the save button. Now open the setting of second label, click on add data stream and select absolute pressure V1 and click on save button. Now open the setting of third label, click on add data stream and select SL pressure V2 and click on the save button. Now open the setting of fourth label, click on add data stream and select computed altitude V3, click on the save button. So we have configured all the widgets in the web dashboard. Now click on the mobile dashboard tab. From this tab, you can get the link to download the new Blynk IoT mobile app for your iOS or Android mobile. And now click on the save button to save the changes in your project template. And guys, I have received lots of queries that they didn't find the NodeMCU or ESP32 board while trying to add via the new Blynk2.0 mobile app. It's due to misconfiguration of NodeMCU. So I am telling you the simple trick of how to resolve it. So what do you need to do? First, download the demo program for Blynk2.0 and upload to your NodeMCU or ESP32 board and connect your board with the Blynk mobile app. So go to the video description and download the demo code for NodeMCU or ESP32 board. Once downloaded, you will get the WinRAR file with the name Blynk2 NodeMCU demo. Right click on it and click on extract here. If you don't have WinRAR or Winzip software to unzip it, then a link is available in the video description to download these softwares. Once it's unzipped, you will get the folder with the same name. Go inside the folder and open the program. In the top of the program, you can see the template ID and device name. You need to change these blank credentials with your blank credentials. So go to your Blynk Cloud dashboard. In the info tab, you will see the firmware configuration. Copy these credentials and replace it in the Arduino code. Now we need to add Blynk library to our Arduino IDE. So we go to the sketch tab. Here we select the include library and click on the manage library. Your computer must be connected to the internet for it. It will download the list of all installed and available libraries for the Arduino. Here we search for Blynk. As you can see, we got the Blynk library at the top. You got the install button here. Once you click on the install button, it will automatically add it to your Arduino IDE. I have already installed the Blynk library. Now connect the NodeMCU board to the computer's USB port and select the Wi-Fi board. So go to the tools and click on the board. Scroll below and select the NodeMCU 1.0 ESP12E module. If you don't know how to install the ESP32 or NodeMCU board to the Arduino IDE, then a link is available in the video description that will show you how you can install it to your Arduino IDE. If you are using ESP32 board, then select ESP32 Brewer board. After selecting the board, go to the tools and then port and select the port COM8 as I do. Now click on the upload button to upload the program. As you can see, the program has been uploaded to NodeMCU board. Now time to download and configure the new Blynk 2.0 mobile app. So go to the App Store and search for Blynk. And Android users, they can download it from the Play Store. As you can see, we have got the Blynk app legacy version, which means this is an old version. Scroll below and you can see the Blynk IoT new app. You need to install this app. Once downloaded, open the Blynk app. Two options here, sign up or login. As we have already created an account with Blynk, so log into it. Dashboard has been opened. This time turn on your mobile data, because in this process to connect your NodeMCU board to Wi-Fi, it uses your mobile data. So click on add new device. As you can see, we have three options: connect to Wi-Fi, scan QR code and quick start device. Click on the connect to Wi-Fi option. Now we have the ready button. The NodeMCU board must be powered on at this time. After it, click on the ready button. Guys, as you can see, we have got a pop-up that starts with Blynk. Note it here. If you didn't find any Blynk pop-up here, then go to your smartphone's Wi-Fi setting and search for new Wi-Fi. Definitely you will find your board that starts with the Blynk. Select it and back to the Blynk mobile app and click on ready. You will get the pop-up. Click on join. Now it is asking to connect the NodeMCU board with external Wi-Fi. So choose your Wi-Fi in which you want to connect NodeMCU. Provide the Wi-Fi credentials and click on continue. Wait for 5 to 10 seconds to configure. Once it is connected to Wi-Fi, it stores the Wi-Fi credential and token to the EEPROM of your Wi-Fi board. Once a profile is created, then click on continue, then done. Now exit from the app and back to the main dashboard of the Blynk. So this way we connect our Wi-Fi board to the Blynk 2.0 mobile app and web dashboard. As you can see, it's online. Now add widgets to our mobile app. So click on your project template and click on the setting icon. Inside it, click on the plus icon. Widgets have appeared. Scroll below and click on the gauge widgets to add it to the dashboard. We added 4 gauge widgets to our dashboard. We arrange them accordingly. Now add value display widgets to the dashboard. We also add 4 value display widgets. We arrange them accordingly. Now we click on the first value display widget. Property gets opened. In the property, we align the title to the center. Click on select data stream and select temperature V0. Increase the font size to the large and back to the dashboard. Now click on the second value display widget. Property gets opened. In the property, we align the title to the center. Click on the select data stream and select the absolute pressure V1. Increase the font size to the large and back to the dashboard. Now click on the third value display widget. In the property, we align the title to the center. Click on the select data stream and select the sea level pressure. Increase the font size to the large and back to the dashboard. Now click on the fourth value display button. In the property, we align the title to the center. Click on the select data stream and select computed altitude V3. Increase the font size to the large and back to the dashboard. Now configure the gauge. Click on the first gauge. In the property, we align the title to the center. Click on the select data stream tab. Select the temperature V0. Increase the font size to the large and back to the dashboard. Now click on the second gauge. In the property, we align the title to the center. Select the data stream as absolute pressure V1. Increase the font size to the large. Change the gauge color to red and back to the dashboard. Now click on the third gauge. In the property, we align the title to the center. Select the data stream as sea level pressure V2. Increase the font size to the large. Change the gauge color to navy blue and back to the dashboard. Now click on the fourth gauge. In the property, we align the title to the center. Select the data stream as computed altitude V3. Increase the font size to the large. Change the gauge color to green and back to the dashboard. So this is how our dashboard looks. Now time to download the main program code for BMP180 interfacing with Blynk 2.0. So go to the video description and download the code from the link. After downloading it, you will get the folder named BMP180 NodeMCU. Right click on it and click on extract here. You will get the folder with the same name after unzipping. Go inside the folder and open the program. Again, you need to change the credentials of Blynk. So go to your Blynk cloud dashboard. In the info tab, copy these credentials and replace it in the Arduino code. Now you need to download 3 libraries for this project: Adafruit SSD1306 for OLED, Adafruit GFX library, and BMP180 sensor library. And guys, download and add the library to the Arduino IDE as I am showing in this video, because we have made some changes in the library so that it will support the hardware smoothly. So go to the video description and download the Adafruit SSD1306 library from the link. Once downloaded, you will get the folder named Adafruit SSD1306 master. Right click on it and click on extract here. You will get the extracted folder. Again, go to the video description and download the Adafruit GFX and BMP180 sensor libraries from the link. Once downloaded, you will get the folder named Adafruit SSD1306 master and SFE BMP180 master. Extract them. You have got all 3 folders. Copy these folders and go to the location where you have installed the Arduino software in your computer. Go inside this Arduino folder, and inside it you will get the folder with the name libraries. Go inside it and paste all the folders here. So we have added the libraries to the Arduino IDE. Now back to our Arduino program. Here we define the Blynk firmware version. After it, we define Blynk serial to print the data serially. After that, we define the NodeMCU board and we define Blynk agent header file. Here we define the required libraries for our program like BMP sensor, SPI, wire, Adafruit GFX and SSD1306. Here we define the OLED screen pixel width as 128 and height as 64 because our OLED has 128 x 64 pixels. Here we define the reset pin for OLED. Now we call the OLED display. Now we define the pressure variable for the BMP180 sensor. Here we define the altitude for 30 meter as it is sea level altitude at our Dehradun corporate office. Here we take the status variable as character type, and we take a few variables as double to store the BMP180 sensor parameters. We are not using this variable in the program, so I am deleting it. I have made a BMP data function to calculate and display the BMP sensor data to OLED as well as in the Blynk dashboard. So first we clear the OLED display by display.clearDisplay function. Now we define the text size as 2. You can define the text size as per your requirements. Now we define the text color as white and set the cursor to 1,1 pixel of the OLED. Now I print the text as SME on the OLED screen. Now we start storing the temperature that we extract from the BMP180 sensor by using pressure.startTemperature command, and we store all the bytes till status will not get 0. Now we print serially the temperature in degree as well as in Fahrenheit. At the same time, we store it in the OLED internal memory so that when we get all the data from the BMP180 sensor, we will display it in OLED. So we set the text size as 1.8 mm, text color white, and set the cursor at 1,25, which means first column and 25th row in OLED, and print the temperature in degrees. We also send temperature data to the V0 virtual pin of the Blynk2.0 server by using blynk.virtualWrite command. Now we store the relative pressure to status variable from the BMP180 sensor till we didn't get 0. Once we receive it, we extract it and serially print it in the millibar as well as in inches. At the same time, we set it to display in OLED. So we set the text size as 1.7 mm, text color as white, set the cursor at 1,35 and print the pressure till 2 place. We also send it to the V1 virtual pin of the Blynk2.0. Now we store the relative pressure in P0 variable and serially print it. Similarly, we discussed earlier, we set the text size as 1.5 mm, text color as white, set the cursor at 1,45 and print the relative pressure till 2 place in the OLED. We also send it to the V2 virtual pin of the Blynk2.0. Now we store the composite altitude in A variable and serially print it. We set the text size as 1.5 mm, text color as white, set the cursor at 1.1,55 and print the relative pressure till 2 place in the OLED. We also send it to the V3 virtual pin of the Blynk 2.0. And this is the main function of the OLED display. We need to print all the data that we stored in the OLED internal memory. Then we have to write this command display.display. Once we write this command in our program, all the data like temperature, pressure, altitude we stored in variables will display in OLED. Here we call the else function for all the data we extracted from the BMP180 sensor. If we are not getting data, then it will print an error message serially related to that value. So here our BMP data function has been finished. Here we made another function named init sensor. We initialize the function for OLED and BMP sensor inside it. Here we begin the OLED display with I2C address 0x3c. 0x3c is the I2C address for the 128x64 OLED. If OLED works, it will serially print the message. Now we clear the OLED and display the message BMP180 sensor interfacing with Blynk 2.0. After 2 seconds, we initialize the BMP180 sensor. If it is okay, then we will serially print the message BMP180 init success and same message will display on OLED. But if it fails to initialize, then we will serially print the message BMP180 init fail and the same message will display on OLED. Now coming to the setup function, we begin the serial port as 9600 baud rate. After it, we begin the Blynk agent function so that our board will connect to the Blynk cloud. After 2 seconds, we call the init sensor function that will initialize the OLED and BMP180 barometric sensor. Now in the loop function, we call the Blynk agent.run function to call all the Blynk functions. And below we call BMP data that will fetch all the data from the BMP sensor and display them to OLED as well as send that data to Blynk 2.0 cloud mobile app as well as in the web dashboard. So our programming code for the BMP180 sensor has been finished. So now attach your NodeMCU board to your laptop or computer and select the board as NodeMCU 1.0 ESP32 module and port as COM80 as I have already shown earlier in this video. Click on the upload button to upload the program. As you can see, the program has been uploaded. Now time for the live testing of this project. Let's power it up. BMP180 sensor has been initialized successfully and all the parameters are displayed in the OLED. There is some issue with my OLED, so it's displaying some blur on it, so avoid that. You can also check all the parameters serially. Let's see the data in the Blynk 2.0 Web Dashboard and mobile app. So first go to your Blynk dashboard and click on the search tab. And here you find your device. Click on it and here you can see the live data of the BMP180 sensor. You can also see the live data in the Blynk mobile app also. So guys, this is how you can measure temperature, pressure and altitude using a BMP180 barometric sensor with Blynk 2.0 IoT mobile app and web dashboard and also display them to OLED. If you have any query or suggestion, write it in the comment box below and thanks for watching. Please like, share and subscribe to our channel and videos. And don't forget to click on the bell icon to get all the latest update of our videos. All the material related to this video available in the video description. You can download it from there.